Okay.
One intro.
What am I drawing?
A square.
That's a triangle.
There is a square.
Leave it room. A right triangle.
Whoa.
Okay. You guys remember what this side is called?
Hypotenuse.
Hypotenuse. The way you spell that is hypotenuse. Okay. What are these other two sides called?
The legs.
Yeah, legs. Okay, the hypotenuse is always the biggest, it's always across from the 90, and the legs are just the other two. Okay, usually we call these A, B, and C, because what do we know about A, B, and C?
A squared plus B squared equals A squared.
Equals C squared. Okay.
Yeah.
So this trick only works if we know two sides of a right triangle, right? Then we can find the missing side. So what we're learning today, trigonometry, right there. I don't think that's on the video.
You spelled it right. You spelled it right. We're doing the syntax stuff.
You know how to spell trigonometry.
You just
That is big.
Anyway, trigonometry helps us find other missing parts of the triangles, not just a missing side, missing angles. So if we had only one missing side, we can use Pythagorean theorem, but if we have two missing sides, but at least another angle, we can use trigonometry. Basically, it's based off of similar triangles. All similar triangles, just like last chapter, have the same ratios. And here are the ratios. Okay. Let's start with this. Sine, cosine, and tangent. You guys have seen these buttons on your calculator. On your calculator, they look like sin, cos, and tan. But it's sine, cosine, and tangent. So here's what they do. I kind of wrote it up here already. I think that's visible on the computer, so I'll go ahead and point to this. Notice on all three of these functions, they have a little x with a little degree symbol by it. What does that mean?
X to the 0 power?
It means x is an angle. So what these functions do is they spit out, you feed them an angle, and they spit out what the ratio should be. Okay?
Wait, so could we have done this when we learned our ratios things and give this answer? Yes.
Kind
You just
of.
didn't want us to cheat. What
No,
is that?
this is tricky stuff to learn. It's not any easier than what we did last chapter. It's not super hard. There's just so much that go over that you might get confused. Anyway, so you feed the sine function an angle, and it's going to spit out a ratio. Okay, the ratio it spits out, I already wrote it up there, it's called opposite over hypotenuse. What does that mean? Well, back to our drawing here. If this is side A, usually we call this angle A. And if this is side B, we would call this angle B up here. And then side C, angle C. C is 90 degrees. So, what is the opposite side relative to angle A? You guys want to guess?
A.
What's right? Side A is opposite of angle A. Okay. Later on, we've got something called adjacent. So you guys know, like, if you say they live opposite me, what is that? Where do they live?
Across the street.
Across the street. If they live adjacent to me, now we probably wouldn't use that word, but adjacent just means next to. So, like, Jordan is adjacent
Joseph?
to Joseph. Sorry, I was thinking Josh, and I knew that
How
was
many
right.
times does it happen?
So Jordan is opposite me?
Well,
If she is turned around,
yes, if she was turned around.
Notice how the abbreviation for sine is sin.
Yes.
This is satanic conjuring
Okay.
and stuff.
What was I talking about? Adjacent.
Yeah.
So what angle is what side is adjacent to angle A? Well, B and C are both adjacent, but we call C the hypotenuse. So just this side, B, would be adjacent to angle A. Okay, relative to angle B, what side is opposite of angle B? Side B.
Oh.
Okay, that's why we name it B. Because the side angles are, same side angle are opposite each other. What side is adjacent to angle A or B? Right, this one. Why is it not this one?
Because it's the hypotenuse.
Because we call this one the hypotenuse. Okay, adjacent means next to, but not the hypotenuse. So this side is adjacent to B, this side is adjacent to A, and C is the hypotenuse for them both. Okay, you don't do angle. Angle C is not really used on these. Okay, you will need to have all these functions and their ratios memorized. Okay, there's a magic word to help us with this. It's called SOHCAHTOA.
Sounds Navajo.
Yes, I just thought it sounds Native American. What do you think so means right here?
Sine opposite hypotenuse.
Right. The sine function gives you the opposite over the hypotenuse. Cosine gives you adjacent over hypotenuse. And tangent, I don't think this is on the screen. Tangent gives you opposite over adjacent.
Or we have those on our calculators too.
You have sine, cosine, tangent in your calculator, yeah.
No, but the saw or whatever.
SOHCAHTOA?
I don't know.
Oh, never mind. There's on the H.
SOHCAHTOA. So tomorrow I'm going to ask you, you guys remember the magic word?
Please.
Non-geometry class. It's SOHCAHTOA. In math class, it's because I said so. Also SOHCAHTOA. I asked somebody once, who shall go unnamed, what's the magic word? And he said, let's get it. It's like, no. SOHCAHTOA. So, let me do a couple examples here. If it's a little muddy right now, that's fine. We'll clear it up as we go. Let's say this is A, B, C. And you guys remember the 3, 4, 5 triangle makes a right triangle? 3, 4, and 5. 3 squared plus 4 squared equals 5 squared. What if I said, what is the sine of angle A? Okay, what the sine does is it spits out the opposite over the hypotenuse ratio.
So it's
So what is the opposite of angle A?
4.
4.
So it's 4 over 5.
Opposite means across from. What is the hypotenuse? 5. So this would equal 4/5. Okay, let's say I knew what angle A actually was. Like maybe it was like 62.3 degrees or something. I'm just making that up. That means if I plug sine of 62.3 in my calculator, if I just plug it in, what it should spit out, it won't spit out 4/5, it'll actually spit out 0.8.
Whoa.
Okay? Because our calculators are smart enough, this is stuff only calculators can do, that it, once it knows the angles, it automatically knows the ratio of the sides of a triangle. Okay. Here's the thing though, just because the ratio of the sides is 4 to 5 doesn't mean the sides actually have to be 4 to 5. It could be like 8 and 10, 12, 15, just in the same ratio. Okay. But 4 and 5 don't reduce, so anyways. How about let's do cosine of angle B. No, actually let's do cosine of A first. Okay, cosine is adjacent over hypotenuse. So relative to angle A here, what's adjacent to angle A?
3.
3. Adjacent means next to. And what's the hypotenuse? 5 still. So this one would be 3 over 5, or as a decimal that'd be 0.6, but just like that. Okay, let's do cosine of angle B. So relative to angle B, looking for adjacent over hypotenuse. What's adjacent to angle B? 4. What's the hypotenuse? 5. So this one will be 4 over 5 also. Notice that sine of A and cosine of B are the same thing, and that's going to happen every time. They're always the same. Just like cosine of A and sine of B. Because when you switch A and B, the adjacent and opposite switch, so it just switches and the same thing. Okay, let's try it. I think we better do a tangent before we get going here. How about tangent of B? Okay, tangent is opposite over adjacent. So what's relative to angle B here? What's the opposite side? 3. Remember, go all the way across 3. And what's the adjacent side?
It's
4. So this would be 3/4. There is a way to use trig to find, if you know the sides, to find the angles, but that's not today's lesson. And if I teach it today, our minds will probably melt because there's too much info already. All right, now we're going to do the odds. Ready, set, page 585.
What?
Does anybody have any picture?
Yes. But you have to come here to get it.
The sacrifice he's not willing to make.
Oh, making
Chasing newspaper.
Yes, ma'am.
Jordan's the provider now that Austin's gone.
I'm surprised you just
I'm
offered.
getting everybody's names backwards. I'm called Austin Aiden.
Thank you.
David is Daniel. Joseph is Josh.
Jordan is Dorothy.
Nick is Nick.
My brain's melting. All right. We're going to do the odds. These take some work. Actually, I wish they would have started with some simpler problems, but you're jumping in too quick. But
Deal not easy to get off.
whoa.
Wrapping. Hello?
What?
Oh,
Hello.
you're a dad.
Is it me you're looking for? 5, 6. Okay, I just copied number 1 down. You don't have to do that. But it's asking for cosine of A, and A is in the bottom right corner. So cosine is adjacent over hypotenuse. What side is adjacent to angle A?
6.
6. Which side is the hypotenuse?
Square root of 60.
Square root of 61. Now we've got a couple issues today. What's wrong with this problem?
That's not rational.
You're not supposed to leave a square root in the denominator, any radical in the denominator. And also on some of these problems we're going to have to simplify square roots. 61 does not simplify because it's prime. There's no double, you can't do the tree on it. There's no double anything in it. But we can't leave it in the denominator. You guys remember how we fixed it by hand? Multiply it by itself, and if you multiply the bottom by a number to keep it equal, you have to multiply the top by the same number. Or have a Casio. That's the other way. Is that mine?
Figure it out.
No, this is mine. Mine is a
I do have a Casio somewhere.
It's in that box.
People, yeah, it always moves. But by hand, what's square root of 61 times square root of 61?
60.
61.
Yeah.
And the top that doesn't really simplify, you just put it together. Yes, a square root squared, those cancel out, they're opposite, so it's just a normal 61. If this would have reduced 6 and 61, I should reduce it, but it doesn't. That's it. Holly, did you find a tutor for last week?
My sister helped me.
Did she? Okay, that's good.
I have like one on the lessons.
Number 3. Sine of A, I'm not gonna write this one down, just the answer. Okay, sine is opposite over hypotenuse. So, Joseph, on number 3, what is the side that is opposite angle A? Oops, I do have to write this one down. Forgot about that. Trick question. The side opposite to angle A is this one right here, right?
Yeah.
They don't give us the number, so how do we find the number?
A squared plus B squared
Yep.
equals C squared, so 11 squared plus 5 squared equals
Not quite.
what?
11 is the hypotenuse, it's the big side, so it
Oh
would,
no, I don't even know how to do it the reverse way.
so it'd be 5 squared plus x squared equals. So the little one should always add up to the big one, Jordan. And,
So it's 5 squared minus 11 squared?
well, yeah, you said it backwards, but yeah.
Yeah.
So yeah, the quick way you can do it is 11 squared minus 5 squared would equal x
Square
squared.
root of 96. Right?
Yes. And what's the square root of 96 simplify to?
4 squared is 6.
4 squared.
Yeah, if you break this down, it's like 16, 4. Anyway, it's 4 squared root of 6.
Wait, wouldn't,
What are you gonna say, Nick?
oh wait, never mind, it would be the same, I was gonna ask why.
Oh yeah, if you break it down to 2's, you're gonna get,
It'd be the same, right?
yeah, it's 2 times 2 times square root of 6, so it's still 4 squared root of 6. All right. Joseph, back to you. What's the opposite of angle A? Sorry, we were doing sine of A, right? Yeah, sine of A. What's the opposite of angle A, Joseph? Yeah, 4 squared root of 6. And what's the hypotenuse? 11. Does that simplify?
No.
No, thankfully not. We already simplified the square root, and 4 and 11 don't reduce, right? So that's it. Number 5. By the way, we're not going to make it to 22 today. Eventually we will, but tomorrow. Okay, sine of B. Sine is opposite over hypotenuse. We keep getting the sines, don't we? Oh, this is left. Sine is opposite over hypotenuse. Notice on number 5 they don't have the hypotenuse. So how could I find the hypotenuse?
4 squared plus 6 squared equals 6
Right.
squared.
So that would be 16 is 52. So what is the square root of 52? What for sure goes into 52?
2 and 3.
2 and 26. That goes into 26.
2 squared root of 13.
So it's 2 square root of 13. Oh, come on now. Oh, I didn't draw it. Never mind. Okay, I guess I better draw it. There. Okay. Sine of B, and B is up here. Okay, sine of B is opposite over hypotenuse. So, Jordan, what's the opposite of angle B?
Angle, no, 6,
Yes, and what's the hypotenuse?
2 square root of 13.
Right. So it's 6 over 2 squared of 13. And Jordan's calculator can handle this, but for the rest of us, what do I need to do? Okay, can't leave 13 square root of 13 down there, so I'm going to do this. So the top is 6 square root of 13. The bottom, actually I probably should have reduced 6 and 2 up front here. That would have made it easier. I could reduce it at the end or at the beginning. Yeah, 6 and 2 are 3 and 1. So it's 3 square root of 13. Square root of 13 times square root of 13 is 13. Times 1 doesn't really matter. So that is the final answer. Number 7, next page. Okay, 7 says sketch a right triangle that has the given ratios. So we're going to make our own right triangle. Doesn't really matter what the picture looks like, but they've been putting B up there and A down here, so I'm just going to do that. Not that it matters. We're just going to label the sides with the ratio they give us, basically. So 7 says cosine of A equals 2/5. Alright, cosine is supposed to equal the adjacent over the hypotenuse. So the adjacent over the hypotenuse is supposed to be 2/5. So the adjacent is 2. So relative to angle A, what side is adjacent to A? The bottom left or top right?
Left. Or
Top
well,
right.
the bottom.
Bottom.
It's the bottom.
Bottom is adjacent to A, so I'm going to put my 2 down there. And then which side's the hypotenuse?
Right
The big side, maybe. That's the picture. Not an accurate picture, but the 2 and the 5 are the important part. And you have to put A in there also. You just put 2 in there. That picture is actually misleading because those sides aren't necessarily 2 and 5. That's just the ratio of those sides is 2 to 5. So they could be 4 to 10 or 6 to 15, just in the same ratio. 2 and 5 is not necessarily the actual length. Number 9, sine of B is 1/2. So I'm going to start with my triangle again. Whoops, sloppy. And it says sine of B. Sine is opposite over hypotenuse. And it's supposed to be 1/2. So opposite, I'm going to put the 1. What's opposite of angle B?
Angle
Well,
Angle.
side, well, the side on the left side. Let's call it the left side. If I called this C, we would call it side AC. But anyway, our 1 goes there. And what's the hypotenuse? AB. There.
Yeah.
11 through 14. This is about as far as we're going to get because each problem has like 6 problems in it. So they're worth 6 points each. So let's not get these wrong. 11. It's a 3, 4, 5 triangle from the beginning of class.
How fun.
Okay, the directions say find the sine, cosine, and tangent of each acute angle on the right triangle below. So there's two acute angles, A and B. Angle A, angle B. And we gotta find sine, cosine, and tangent for each of them. So that makes 6. I'm gonna start with sine of A. This is gonna go kind of quickly until we get to 13, then it'll go slowly. Sine of A. Sine is opposite over hypotenuse. So Chase, what's the opposite of angle A?
B.
Which side, 3, 4, 5, is opposite angle A?
4.
Yes. Which side is the hypotenuse?
The 5.
Okay, that's it. Then I'm going to do cosine of angle A. So cosine is adjacent over hypotenuse. What's adjacent to angle A?
5. No.
Adjacent means next to, but not the hypotenuse.
So 3.
So it's 3. And what's the hypotenuse?
5.
And tangent of angle A is opposite over adjacent. What's opposite of angle A?
Well, B, but 4.
4. Well, both the angles are kind of opposite, but it's the side that's opposite. That's what we're looking at. 4. What's the adjacent?
3.
And okay, now I'm going to do sine of angle B. So who else wants to try this? David, what's the sine of angle B? So what's the opposite of angle B? 3. What's the hypotenuse?
5.
Okay, what's the adjacent to angle B? 4. And what's the hypotenuse? So notice these two are the same, and these two are the same. That always happens. Cosine A, sine B. Tangent of B would be opposite over adjacent. What's the opposite of angle B? 3. What's the adjacent? 4. So how are the two tangents related?
They're flipped upside down.
Yeah, they're inverses, they're reciprocals, I mean, of each other. So 4/3, 3/4. That always happens too. Because you're switching the opposite of adjacent when you switch the angles. Okay, 13. This one is much more challenging. If you have a Casio, it's not as bad. Okay, it says 4 and 2. So what do I need to do first? Pythagorean theorem. This is B. This is A. 4 squared is 16. 2 squared is 4. 16 plus 4 is 20.
20 doesn't square root.
Square root of 20 is basically 2 square root of 5, right? Square root of 4 is 2. 2 square root of 5. So it's the square root that makes it messy. That's what makes it a little bit harder than the last one. We're going to have square roots all over the place. Alright, here we go. Sine of A. So opposite and hypotenuse. Joseph, what is the opposite to angle A?
4.
4. And what is adjacent to angle A? Or sorry, forgot what I was doing. What is the hypotenuse?
2 squared.
Yeah. Hypotenuse is always the big one. It's always the angle across from the 90-degree angle. It's always the largest. 2 square root of 5. Okay, so we got a couple problems. One, it reduces 4 and 2. And the other is we can't leave square root of 5 on the bottom. This is where the Casio makes it easier. So it's 2 square root of 5 over 5. And that doesn't reduce, so that's it. 13 is about as hard as it gets, probably. Probably. And no, I take that back. 15 through 22 is about the same. Cosine of A. Joseph, what is, cosine is adjacent, so what is adjacent to angle A? 2. What is the hypotenuse? 2 squared of 5. So in this one, the 2's cancel out, and you can put 1's in their place. We need a 1 for the top. And then you multiply by square root of 5. So we got 1 square root of 5, square root of 5, over square root of 5 times square root of 5, which is normal 5. When you square a square root, square roots cancel out. Tangent. This one is much simpler. Tangent of angle A. Tangent is opposite over adjacent. So Joseph, what's opposite to angle A? And what's adjacent to angle A? Alright, and what's 4 over 2? Reduce 2? Just 2. You guys have these written down? I want to erase it. Okay, because I'm just going to put the B's and then kind of out of room. Alright. Jordan, sine of B is opposite over hypotenuse. So what is the opposite to angle B?
2.
What's the hypotenuse?
2 squared of 5.
Oh shoot, I didn't want to erase that. Which other problem did we get 2 over 2 squared of 5?
The sine for A.
No,
Yeah, we did.
cosine of A.
Oh.
Anyways, and what did we get for cosine of A? Square root of 5. So that's just kind of cheap. Use our answers from before to help us. Okay, Jordan, cosine is adjacent over hypotenuse. So what is adjacent to angle B?
4.
Yep. And the hypotenuse?
2 squared of 5.
Okay, what other problem did we get 4 over 2 squared of 5 on?
That was the sine for
Sine of A. And what did that simplify to when we did it?
2 square root of 5 over 5.
Whoa. 5's out of control. The hats keep getting longer. Alright, tangent of B. Tangent is opposite over adjacent. So Jordan, what's the opposite of angle B?
Angle A.
Not angle, sides. What side is opposite of angle B?
2 squared of 5.
No.
2.
Opposite, directly across from.
Okay.
These would be like next to angle B, like around angle B. Anyway, 2, and then what's the adjacent to angle B?
4.
Yeah. And what's 2 over 4 reduced to? Oh, that isn't working.
I mean, wait, what?
Too close to each other.
1 over 2.
Yeah.
Yeah.
Alright. Notice how tangent of A and tangent of B are related. Tangent of A was 2, or 2 over 1. Tangent of B, 1 over 2. Alright. That's all the farther I made it with the other class. See, for the 10 minutes, I want you guys to train the evens. And finish it tomorrow.
So we're gonna work on it tomorrow.
Yeah. So I want you guys trying to get to 14 today if you can.
Hey Jordan, I have a piece of paper.